Hello everybody. We're going to take a look at Unit 2.3H, which is the last of the 2.3 series, which is fractions. And we're going to look at how to divide fractions and whole numbers. All right, so the first one is 4 divided by 3 halves. And the second problem is 5/8 divided by 6. So we're going to divide a whole number by a fraction in the first one, and a fraction by a whole number in the second one. So let's take a look at the tablet and see how that's done. Okay, so easiest thing to do for dividing fractions, if you have both fractions, it should make more sense. So 4 can be turned into a fraction by using a 1 in the denominator. So let's rewrite that. As we'll rewrite this problem as 4 over 1 divided by 3 over 2. And we're going to do the keep, change, flip. Keep, change, flip method of division, or it's also called invert and multiply. Invert and multiply. So working from 4 over 1 divided by 3 over 2, or 4 firsts divided by 3 halves, we're going to keep the 4 firsts, so 4 over 1, and we're going to change the division symbol to multiplication, that's using the inverse, and then we're going to flip. We're going to flip that fraction. So the denominator and the numerator have traded places. And now we're just going to treat it like a regular multiplication problem. So multiplication of the inverse is equivalent to division by the original fraction. So this, we just multiply straight across the number of pieces, 4 times the number of pieces, 2, which is 8. And then we've got the number of units, and this is 1 in this case, so it's a whole. And then we've got 4 whole pieces, and then we have 2/3. So the size, the unit for this is 3. So 1 times 3 gives us 8 over 3. And all we have to do from here is either reduce it or change it into a mixed number. And let's check what it says at WAMAP. Sometimes they don't want you to turn it into a mixed number, and here they say write as an improper fraction or a whole number. So we don't have to change it to a mixed number. They either want a whole number or an improper fraction. And over here we have an improper fraction, 8 over 3. So that's what we'll use as our answer. And then let's take a look at the next problem, which is 5/8 divided by 6 over 1. 5/8 divided by 6, so it's the same process. We can put 6 over 1 and make it a fraction in its own right. So 5/8 divided by 6 over 1. We're going to rewrite the problem first. And then we do the keep, change, flip, or invert and multiply. So we're going to use the same. 5/8 will not change, and then we'll go to multiplication. And then we're going to invert this 6 over 1 to make it 1 over 6. And multiplication by the inverse, and this is the multiplicative inverse, is the same as division by this 6 over 1, which is equivalent to division by 6. So we're taking 1/6 of this, which is the same as dividing something by 6. All right, so to multiply this fraction, move this out of the way, we just do the number of pieces times the number of pieces. We have 5 times 1, which is 5. And then the size of each piece, we have 1/8 here, and we have 1/6 here. We multiply those together to get 48. And this is our new answer, 5/48. And all we have to do is see if we can find a factor that works for both of these numbers to reduce it. So the factor, 5 is a prime number, so it only has one factor, 5. 48 has many factors, but 5 is not one. If you remember, The rule for divisibility by 5 is that the number end in 0 or 5, and those are the only ones that can be divided by 5. So these are not factorable. They are what we call coprime, which means they don't share any factors in common. And that means we have this fraction is reduced as much as it can be. So let's take these answers to WAMAP and see how it turns out. So 4 divided by 3 halves, we decided, was 8 thirds, so 8/3. And if we hit enter, we should see that is correct. Okay. And then 5/8 divided by 6, we got 5/48, 5/48. And I got a typo in there. You always want to check your answers before you hit enter. And this one was also correct. So just remember that we're going to change this whole number into a fraction by putting 1 in the denominator. We did that both times. And then if it's the divisor, the second of the two fractions, that's the one that's going to be flipped over. You use the inverse of that one. Let's see if we get anything interesting if we do a similar 7 divided by 3 over 1. And this one, 3/7 divided by 12. Let's go ahead and run these two. So let me get a new color. We have 7 divided by 3 over 1, which is the same as 3. So this is going to give us the same answer as 7 divided by 3. And then we have 3/7 divided by 12. So if you were going to cut that into 12 pieces, what would it become? Right. So some of these are hard to imagine, and we're getting a little more abstract each time as we move higher up in math. And so we just have to make sure we're really following the rules and applying them each time. So for this problem, 7 divided by 3 over 1, we're going to turn 7 into a fraction. And so we're going to rewrite this in an equivalent form as 7 over 1 divided by 3 over 1. And then we're going to apply the keep, change, flip, or invert and multiply idea. So 7 over 1 is the same. We go to multiplication and then we write the divisor. The second fraction gets written as its inverse, so upside down. And now we just treat it like a regular multiplication problem. 7 times 1 is 7, and 1 times 3 is 3. And because they don't want us to reduce they want us to reduce the answers but not turn them into a mixed number, we'll just use this improper fraction. So this is the answer. And basically what this says is 7 divided by 3 in a fraction form, which is what the original problem was asking. All right, so the last one, 3 over 7 divided by 12. We're going to turn the 12 into a fraction, 12 over 1. And then we're going to keep, change, and flip. And we're going to just multiply straight across. Let's get that on camera. 3 times 1 is 3. And then 7 times 12 is 84. And so if we can't find a common factor for these two, then we'll just go ahead and use this fraction. But let's see, will 3 go into 84 evenly? I think 12 goes into 84 evenly. Do you remember the number for divisibility for 3? We add up the digits, 8 plus 4 is 12, and if that number is divisible by 3, then the original number, 84, is also divisible by 3. So we're going to divide, let me change colors. We're going to divide the top and the bottom by 3. And we're going to get 1. 3 divided by 3 is 1. 84 divided by 3 is 3 goes into 8 twice with 2 remainder, and 3 goes into 24 8 times. So here we have a unit fraction, 1/28. So we do have to reduce, but if we have an improper fraction, we don't have to change that to a mixed number. Okay, so let's plug these answers in and see how we did. All right, the first one was 7/3, 7 over 3, and doesn't look like they found any syntax errors there. We'll submit this question. That's correct. And the second one, 3/7 divided by 12, we got 1/28. Let's see how we did there. And that one is also correct. So if you have 3/7 and you divide them into 12, you're basically multiplying this denominator by 12 because you're cutting it in. Each piece gets cut into 12 more pieces, which is how we ended up at 3/84. And then because 12 is divisible by 3, then the number that's multiplied by 12 will also be divisible by 3. And the divisibility rule is if the numbers add up to a number that can be divided by 3, it's divisible by 3. Okay, why don't you give this a try and see how you do. I think if you just put, when you have a whole number, use 1 as the denominator and treat it like a regular fraction and you'll do fine. Give it a try, and if you get stuck, send me a message from within WAMAP.